Hi everybody, we are in your book on page 41. We're going to work on lesson 5 in unit 1 today. Our ideas for the day, our goals for the day, we should be able to describe the effect on a scaled copy when I use a scale factor that is bigger than 1, that's less than 1, or that's equal to 1, and explain how the scale factor that takes figure A to figure B is related to the scale factor that takes figure B to figure A, and there should be another R in there. So first thing I want you to do is check out these questions. It says solve each equation mentally, which means we have no calculators. All we're doing is trying to figure out what number stands in for the x. So this means 16 times what gives me 176. So take some guesses or do whatever it is you can to figure that out. Try to do it without any paper. Try to do it just using what you know. Can you picture it? Can you close your eyes and figure out how many times 16 fits into 176, or 16 times what number would be 176? Think about your strategies. What did you do to get there? How about 16 times what gives you 8? So now you're getting smaller. 16 times what number gives you 1? Again, you're getting smaller. Or if we have a fraction, 1/5 times what number gives you 1, or 2/5 times what number gives you 1. I want you to pause here and do your very best to try to come up with those 5 answers. Give yourself a few minutes and try to come up with them, okay? If you get them wrong, that's okay, but give it a try. So for me, for this first one, the easiest way for me to do that is just think long division in my head. So I think 16 goes into 17 once. And if I picture that long division, I subtract, I get 1, and bring down the 6, there's another 1. But maybe some of you thought 16 times 10, I know is 160. And then if I add one more group of 16, I get to 176. So that would be 11. So our answer there is 11. There's lots of ways to get to our answer. How about 16 times what is 8? Well, 8 is half of 16, so our answer there should be a half. You could say 0.5 as well. 16 times what is 1? Well, let's see. 16 times something is going to give me 1. I need something that's going to wipe out that 16. Well, how about 1/16? We know when we multiply fractions, we multiply across. Or we can simplify first. 1/16 would give us 1. Similarly, 1/5. I need something to wipe out that 1/5 to give me 1. Well, if I multiply by 5/1 or just 5, I would get 1. I could do that with, you hear my door squeaking in the background. 2/5. 2/5 times what would give me 1? Well, let's see. I need to wipe out that 5, so I'm going to put a 5 in the numerator, and wipe out that 2, so I'll put a 2 in the denominator. And now I get an answer of 1. So there's our 5 solutions. We have 11 for the first one, 0.5, 1/16, 5/1 or just 5, and 5/2 for the last one. How did you do? We have an activity 5.2. It says scaled copies card sort. We're going to do that together in our Zoom meeting on Wednesday. We can skip that at the bottom of page 41. And then we have an activity that says 5.3, scaling a puzzle, and we're going to do that tomorrow together. So we're going to skip that one as well. So we're going to jump over to page 43. At the bottom it says missing figure, factor, or copy. What is the scale factor from the original to its copy? Explain or show your reasoning. So it's at the bottom of page 43, but really the activity is on the next page with these triangles and with these shapes. So turn to page 44. And it's asking us here, what is the scale factor from the original to its copy? So first thing we need to do is figure out which one's the original. And it tells us in this case, the big one is the original and the small one is the copy. So I need to know the scale factor. Well, let's see, I'm going from a bigger one to a smaller one. And before I decide what the scale factor is, I'm going to count some boxes. This triangle on the left has 1, 2, 3, 4, 5 across the top. This one only has 1. So I need to take that side of 5 and multiply it by something to get down to 1. That sounds familiar because that's just like the warm-up that we just did. I need to wipe out that 5. I'm going to put a 5 in the denominator and a 1 in the top. My scale factor, going from a bigger one to a smaller one, is 1/5. Explain or show my reasoning. Well, I'm going from 5 down to 1. I need to shrink it down. I'm going to multiply by a number that's smaller than 1. The second question with this trapezoid says the scale factor from the original trapezoid to its copy is 2. Draw the scaled copy. And we want to think about what we talked about in class. We're going from a smaller one. We have a scale factor of 2. That means it should be twice as big. But again, we can't count on those diagonals, right? We need to count acrosses and downs, acrosses and ups and downs. So I'm going to pick a point to start on. Let's say I start right here. And what I'm looking at is how far across and how far up and down till I get to a new point. So let's say I want to go from this point to this point. I'm going over 1 and up 2, over 1 and up 2. So in my scale copy, because I'm using a scale factor of 2, I want to go double that. I want to go over 2 and up 4. 1, 2, 3, 4. And I'm going to put a dot there. And that's going to be where this corner point is in my new copy. So I've drawn that kind of left-hand side. I can connect the dots from there to there. I'm going to go back to the original. From this point to this point, I'm going up 1 and over 1. So I need to double that in my scale copy. I'm going to go up 2 and over 2, and my new point will be here. So I can connect the dots, and that's the side that corresponds to this side. So take a minute and see if you can finish off, hit pause, and finish off this trapezoid. Okay, we're gonna draw this number 9 now. And the directions say that the scale factor from the original, which is the missing one, to the copy is 3/2. So I'm multiplying by 3 over 2. Well, that's kind of weird. Those are strange numbers. But here's what I know. If the scale factor from the original to the copy is 3 over 2, we've talked about this in class, the scale copy the scale factor from the copy to the original should be times 2 over 3. So I need each of my sides to be 2/3 as big as the original one. So let's see what that means. 2/3, well, let's see. The bottom side here is 3 units long. 1/3, 2/3, 3/3. That means the bottom side on my original should be 2 units long. Going up the side here, 1/3, 2/3, 3/3 should be 2 units long. 1/3, 2/3, 3/3. I need it to be 2/3 as long. Should be 2 units long that way. Hit pause and finish off these pictures in your book. Question 4 says, what is the scale factor from the original to the copy? Well, what do you notice there? The original and the copy, they're exactly the same size, right? So what would the scale factor be? If two things are the same size, the scale factor would have to be, take a guess. I want you to write that down in your book and we'll talk about it. We'll talk about it next time we meet. So for this last task, it's going to ask us to take this number 4, and it says the scale factor from the original to its scale copy is 3. Draw the scaled copy. And what we notice here is, there's no grid here, right? There's no boxes that we can count. But we can do this pretty easily if we just have a piece of paper. So I'm going to ask you to grab a piece of paper, and then let's talk about how we could make this scaled copy with no grid. So let's say this rectangle acts like a piece of paper. What we want to do is use it to measure. So I'm going to slide this over, and I can look at just about how big that number 4 is. So from the bottom of the 4 up to the top of the 4, my piece of paper goes to right about there. So I'm going to slide that rectangle over, and let's see if I can make a line that's 3 times as big. Well, I could draw a line to here, from the bottom of the rectangle to there. So with using your piece of paper, from the bottom of the piece of paper to that mark you put on it. Then I could move it up again. Now it's going to be twice as long. And then I could move it up again. And now it's going to be 3 times as long. So this line that I just drew is 3 times as long as the original 4. And I can do the same thing for the width as well. But before I do that, I should check where that crossbar is, right? So I'm going to move that piece of paper back and figure out how far up that little crossbar is. So I'll change the color here. We'll put the crossbar right about there. And now again, I can move it. And I need that to be 3 times as big. So 1, 2. That's going to be about where the crossbar should be. And now I can do what I did with the up and down piece. I can move this over and figure out how long that crossbar should be. So let's see. If I go just from the edge of that crossbar to where it intersects the line, I really should check that because I need to know how far away I need to be. So if I put a little line right here, I can drag this back and say there's 1 length, a little bit closer, 1 length, 2 lengths, 3 lengths, and I can put a little dot there and know that that's where I should start to draw the crossbar. And so on. I can move that rectangle around and figure out where these things should be. So I want you to take your piece of paper, finish up that 4, just use it as a reference. Make a little mark, everything should be 3 times as big. You could also use a ruler, but we don't really even need a ruler if we have just a handy piece of a paper, okay? I want you to read the lesson summary and highlight, okay? The idea here is that if we get a figure that's bigger, we have a number that's more than 1. If we need it to get smaller, we use a number that's less than 1. If our scale copy stays the same size, the scale factor is equal to 1. And then I want you to do, in the book, lesson 5 practice problems. So you're going to do page 47, number 1, number 2, and then we're flipping the page, number 3, number 4, and number 5. Okay, so numbers 1 through 5 on pages 47 through 49 are your homework for tonight. And that's it, guys. We'll talk to you tomorrow. Bye-bye.